Alright, in this video we will be doing several problems relating to similar figures. So, the first problem, triangle DEF was dilated. That means it either got bigger or it got smaller. In this case, it was dilated according to the rule shown here. Now this 1/3 means that the new image will be 1/3 the size of the original image. So it is shrinking by a factor of 1/3. Alright, now, which statements are true? Check all that apply. Let's see, angle F corresponds to angle F prime. Well, that's obviously true because the letters are the same. F, F prime. Yeah, that's what that means. So moving on, segment E, E prime. Okay, so that's this segment right here from E to E prime, okay, is parallel to segment F, F prime. So here's segment F and here's segment F prime. Are these parallel? No, these are not parallel. Parallel means they are going in the same direction, and if you continue the lines forever, they would still never touch. But you can see that these lines, if you extended them, they touch, they meet right here. So they're obviously not parallel. They're small on this side, and they're getting bigger as you go to this side. You know, they're not parallel like this. So that's a no. Okay, what else? The distance from point D prime to the origin is 1/3 the distance of point D to the origin. So we're saying here's point D, okay, and there's the origin. Alright, so this is the distance from D to the origin, and then this is the distance from D prime to the origin. So D prime is 1/3 of the distance of the original point D. Alright, that's what this 1/3 means. So let's see. So the distance from point D prime is 1/3 of the distance of point D. That's definitely true. Alright, see this whole giant distance? And then D prime is 1/3 of that distance. We knew that because of the scale factor. Alright, let's look at the next one. The measure of angle E prime is 1/3 the measure of angle E. Okay, so when you take these images and you shrink them or grow them, when you do a dilation, the angles don't change. Alright, so for example, look at this triangle. Okay, imagine that this is a 30, 60, 90 triangle. So imagine that this angle right here is 30 degrees, this angle is 60 degrees, and of course this angle right here is 90 degrees. If I do a dilation where I'm going to grab this and I'm going to grow it, guess what? The angles don't change. This is still 30 degrees, and this is still 60 degrees, and this is still 90 degrees. A dilation does not change the size of the angles, just the lengths of the sides. Alright, so will it be 1/3 the size? No. Okay, and then last statement, triangle DEF is similar to triangle D prime, E prime, F prime. Well, of course. It says so right in the problem. Triangle DEF is dilated according to this rule to create similar triangle DEF. So they told you right there that triangles are similar. And just in general, when you do a dilation, you are creating similar triangles. So that's definitely true. Alright, so these are the answers. Alright, in this problem, is trapezoid ABCD the result of a dilation of trapezoid MNQP by a scale factor of 2/5? Why or why not? So, if this is a dilation, then if I make a ratio, if I make fractions out of all the corresponding sides, all of the fractions should simplify down to 2/5. So let's start with the horizontal lengths. Let's see. So the top length here is 4. You know what? Let me change colors. The top length here is 4. And then the top length here is 10. So if I make a ratio out of this, all right, and I'm going to go small over big, just like this, then that would be 4 over 10, which simplifies down to 2/5. All right, so far so good. Okay, so that's the AB and the MN. So those are good. Maybe I'll mark them as I go. All right. Now how about CD, which is 2, and let's compare that with QP, which is 6. So that would be 2 over 6, which reduces down to 1/3. So that's a fail right there. Okay, so let's see, how will I mark these? So I guess everything that turns out to be a no, I will mark in blue. All right, so those are a scale factor of 2/5, but the CD and the QP, that's not 2/5. Okay, how about the MQ compared to the AC? You know what, that's going to be tougher because of the way they're slanted. I'm wondering if we can answer the question just based on these two without using the slanted ones. Okay, let's look through some of these. So for starters, we already know that they are not similar. So we can throw out all of the ones that say yes. Okay, because they are definitely not similar. So we can throw out these two answers. So it has to be one of these. So no, because AB is 2/5 the length of MN. Let's check that. AB is 2/5 the length of MN. All right, that was true. Okay, that one was good. But CD is 1/3 the length of QP. And there's the 1/3 they're talking about. Okay, so this is the answer right there. I don't even need to look at the next one. Okay, so let's look at the last one to see why this is not the answer. No, because sides AB and CD, all right, there's AB and CD, have different slopes from MN and QP. Yeah, see, all of these have the same slope because they are all horizontal. Okay, so the slope of this line is 0 because it's horizontal. The slope of this line is also 0. It's horizontal. The slope of this line is 0. The slope of this line is 0. They're all horizontal. They all have the same slope. Okay, they don't have different slopes. So that's why this is definitely not the right answer. Okay, in this problem, triangle KLM, shown here, is going to be dilated according to the rule shown here. Now, this 0.75 means that the image, triangle K prime, L prime, M prime, is going to be 0.75 as big as the original. So it's going to be a smaller image. Okay, so check all that apply. So the first statement says we can get the new points by taking the original points and just multiplying by 0.75 each of the coordinates. That's true. Okay, will LM be parallel to L prime, M prime? Yeah, that's also true. So, look, imagine that I put my similar triangle here. All right. Let's see how am I going to do this. Okay, imagine that this was my similar triangle. All of the corresponding sides are going to be parallel. All right, see how this side is parallel to this side. See how this side is parallel to this side. And do you see how this side is parallel? Well, okay, these are actually on the same line. But the point is, when you have similar, when you have a dilation like this, the corresponding sides are parallel. So if I say side KL, that's going to always be parallel to K prime L prime. Okay, because they're corresponding sides. Okay, and that's the same thing here. Okay, Km is going to be shorter than K prime M prime. That's false. Okay, Km is the original picture, the original triangle. K prime M prime is from the new triangle. The new triangle is going to be 0.75 times the original. 0.75 is 3/4. So the new triangle is 3/4 the size of the original. So the new triangle is going to be smaller. So the original length Km is bigger than K prime M prime. So that's false. Okay, the vertices of the image are closer to the origin than those of the pre-image. That is going to be true. Okay, the image is the new triangle. The new triangle, because it's 3/4 the distance from the origin, that means it's closer, right? This is less than 1. So everything is going to be closer to the origin. Okay, so yes, closer. The distance from M prime to the origin is exactly half the distance from M to the origin. No, it's not going to be half the distance, it's 3/4 of the distance. If this were 0.5 instead of 0.75, then everything would be half the distance. So it's not half, it's 3/4. So this is wrong. Okay. All right, let's look at the next one. Triangle ABC was dilated and translated. All right, that means it either shrank or grew, and it slid. You know, it was just moved over to form triangle A prime, B prime, C prime. All right, so there's a dilation and a translation. What is the scale factor of the dilation? Okay, so the translation really just has nothing to do with it. So as far as the dilation goes, if I want the scale factor, first of all, you got to understand which one of these is the original and which one of these is the new image. Of course, this one is the original, and this one is the new one. I can tell that because it has the primes, A prime, B prime, C prime. So this is going from small to big. It's getting bigger. That means my scale factor is going to be bigger than 1. All right, it's getting bigger. So the scale factor has to be something bigger than 1. So right away I know that it's not going to be 1/5. That's less than 1. It's not going to be 2/5. Okay, so right away I know it's going to be one of these two. Right, these are the only ones that are bigger than 1. So now let's do some ratios and see which one it is. But when we do it, make sure you do big over small. All right, because the scale factor should be bigger than 1 if it's growing. Okay, so that's why, for example, if I look at these corresponding sides right here, then this is 5. While this is 2. So when I set up my scale factor, I'm going to do 5 over 2 on purpose. I'm going to do big over small because I know the scale factor should be bigger than 1. So I'm going to make it the improper fraction. If the smaller triangle were the A prime, B prime, C prime, which would mean that it's shrinking, then I would do 2 over 5. Alright, so you make it less than 1 if it's getting smaller, make it bigger than 1 if it's getting bigger. So anyway, 5 over 2 is the answer. Okay, one more problem. Triangle MNP, shown here, is dilated according to this rule. Okay, and see the 1.5? That's the scale factor. That tells us that the new points will be further out. You know, it's getting bigger. All right, it's 1.5 times the original distances. So we're going to create the image M prime, N prime, P prime, which is not shown. All right, what are the coordinates of the endpoints of M prime and N prime? Okay, so they're asking us for the new coordinates that correspond with M and N. So let's just do that one at a time. So what is point M? Point M is -4, comma 6. Alright, that's a wicked comma I've got going on there. Don't laugh at me. Alright, that's point M. So if I want to find the new point M prime, I'm going to do just what this says. I'm going to multiply the x and the y by 1.5. So I'm going to do 1.5 times -4, and I'm going to do 1.5 times 6, and that's going to be my new point. Alright, so that turns out to be -6, comma 9. So now let's do the same thing for point N. Point N is the point 2, comma 6. So to find N prime, I'm going to do 1.5 times 2, and I'm going to do 1.5 times 6. Whoops, I changed to M. Hey Siri, 1.5 times 2.
1.5 times 2 is 3.
That's going to be 3. Hey Siri, 1.5 times 6.
1.5 times 6 is 9.
Yeah, my Siri has an Australian accent, so that's what you're hearing. Anyway, N prime is 3, comma 9. So these should be the answers right here. So there's -6, comma 9 and 4, comma 9. That's close, but nah. -6, comma 9 and 3, comma 9. That's it. And that's how you do it.